NCERT Class 10 Chapter 12 Electricity Textbook Exercise Part 1. Question number 1. A piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then the ratio R dash is. So in this problem, they have taken a wire of resistance R. So this is the original wire of resistance R, and this wire is being cut into 5 equal parts. So each wire will be of length, that is each cut wire will be of length L by 5, that is 1/5 of the original wire. And these cut wires are then connected in parallel. So let us assume the resistance of each cut wire to be R double dash. So, and the resistance of this wire is R. So we know that the formula relating resistance and length of wire is R is equal to rho into L by A. So rho is the resistivity of the wire, L is the length of the wire, and A the area of cross section of the wire. So in both the cases, that is the original wire and the cut wire, the resistivity is going to be the same and the area of cross section is also same. So the only change is the length of the wire. So the original wire has a length of L and the cut wire has a length of L by 5. So let us take it as Ln. So Ln is equal to original length divided by 5. So substituting this value in the resistance formula, we get the resistance of the cut wire to be R double dash is equal to rho L divided by 5A. So this each cut wire is connected in parallel. So and this combination is going to be R dash. So we'll write the formula for when the resistance are connected in parallel. So 1 by R dash is equal to 1 by R double dash. That is the resistance of each cut wire. This we need to do it 5 times since 5 resistance are connected in parallel. So substituting, we get 1 by R dash is equal to 25A divided by rho L. And we need to find the ratio R dash. So R dash is equal to, this can be written as R into 1 by R dash. So R we know rho L divided by A into 1 by R dash is what we have found here. So 25A divided by rho L. So rho L gets cancelled and A gets cancelled and the ratio is 25. Question number 2. Which of the following terms does not represent electrical power in a circuit? So in this problem they have given 4 expressions for power. We need to find which expression is wrong. We know that the expression for power, that is the formula for power, P is equal to voltage into current, that is V into I. And as per Ohm's law, we know that voltage V is equal to current I into resistance R. This can also be written as I is equal to V by R. So substituting V equal to IR in power equation, we get power P is equal to I squared into R. And substituting I equal to VR in power equation, we get power P is equal to V squared divided by R. Hence the expression P equal to IR squared is wrong. Question number 3. An electric bulb is rated 220 volt and 100 watts. So the power consumed by this electric bulb at 220 volt is 100 watts. When the same bulb, when it is operated in 110 volt, the power consumed will be. So we need to find the power consumed when the same bulb is operated in 110 volt. So let us take the power to be P1 when it is operated in 220 volt. So P1 is equal to, this is the first case. So P1 is equal to 100 watts and V1 is equal to 220 volt. So in the second case, this is being operated in 110 volt. So V2 is equal to 110 volt. We need to find the power consumed when it is operated in 110 volt. We know that in both the cases, the resistance of the electric bulb is same. So because since the same bulb is operated in a different voltage. And we know the formula for formula relating power, voltage and resistance is power P is equal to V square divided by R. So power 100 watts is equal to voltage 220 into 220 divided by R. We get the resistance to be 484 ohms. So this is the resistance of the electric bulb. So substituting this value for 110 volt, that is power P2 is equal to 110 into 110 divided by 484, we get the power consumed to be 25 watts. So when the same bulb is operated at 110 volt, the power consumed will be 25 watts. This problem can be solved in a different way also. So in this, we are just taking the ratio. So P1 divided by P2, that is power consumed in the first case divided by the power consumed in the second case, equal to V1 square divided by R divided by V2 square divided by R. So in both the cases, resistance is same. So R gets cancelled. So V1 squared divided by V2 squared. We need to find the power P2. So P2 is equal to P1 into V2 squared divided by V1 squared. So substituting, we get the power P2 to be 25 watts. That is the power consumed by the electric bulb when it is operated in 110 volt is 25 watts. Question number 4. Two conducting wires of the same material and equal lengths and equal diameters are first connected in series and then in a parallel in a circuit across the same potential difference. The ratio of heat produced in series and parallel combinations would be. So in this problem, they have taken two wires and the two wires have the same material or of the same material. So that is, the resistivity of both the wires are same and equal lengths. The length of the two wires is also same and equal diameters, and the wires have the same area of cross section. So rho is same, L is same and area of cross section is same. So resistance is also going to be same. So let us assume the resistance of each wire to be R. So these two wires are first connected in series, and so the total resistance when the two resistors are connected in series will be 2R, and then they both are connected in parallel. So when the two wires are connected in parallel, we get the equivalent resistance to be R by 2. That is, if the resistance are connected in parallel and if the resistance are equal, the equivalent resistance will be R by the number of resistance connected in a parallel combination. So here only two wires are connected. So equivalent resistance will be R divided by N is 2 in this case. So R by 2. This is the equivalent resistance when the wires are connected in parallel. And we need to find the ratio of heat produced in series and parallel combination would be. So first we'll write the general expression for heat. So heat produced in series combination would be I squared R into T. So substituting as per Ohm's law, I is equal to V by Rs. So V by Rs the whole squared into Rs into T is equal to V squared divided by Rs into T. So this is the heat produced in series combination. And we will find the heat produced in parallel combination. Hp is equal to V by Rp, that is resistance in parallel combination, the whole squared into Rp into T. and we get B square divided by resistance in parallel combination into T. So we need to find the ratio. So Hs divided by Hp is equal to, we are substituting these two values, and Tt gets cancelled. Voltage V squared gets cancelled because they both are operated across the same potential difference. So reducing this, we get Rp divided by Rs, and Rp we know that R by 2, that is R by 2 into Rs is 2R. So R gets cancelled. The ratio will be 1 by 4. So the ratio of heat produced in series and parallel combination is 1 by 4. Question number 5. How is a voltmeter connected in the circuit to measure the potential difference between 2 points? A voltmeter should always be connected in parallel to find the potential difference. So a voltmeter should be connected in parallel to measure the potential difference between 2 points. Question number 6. A copper wire has diameter 0.5 mm. So this is the copper wire and it has a diameter of 0.5 mm. So radius will be half of diameter, and with that we can find the area of cross section of this wire. And resistivity 1.6 into 10 power minus 8 ohm meter. So this is the resistivity of the conductor, 1.6 into 10 power minus 8 ohm meter. What will be the length of this wire to make its resistance 10 ohms? So we have the resistance of the wire, the resistivity of the wire, and with diameter we have the area of cross section of the wire, and we need to find the length of the wire. So the formula which is relating these parameters is resistance R is equal to resistivity rho into length of wire divided by area of cross section. So substituting the values, R equal to 10 ohms, which is equal to resistivity 1.6 into 10 power minus 8 into length of wire divided by area of cross section, pi r square. So pi 3.14 into R we can get by dividing the diameter by 2. So radius is equal to 2.5 into 10 power minus 4 meters. That is, this millimeter is being converted to standard unit of measurement, meter. So we get the radius of the wire to be 2.5 into 10 power minus 4 meters. So this is area of cross section, pi r square. Substituting, we get the length of wire to be 122.65. Now let's come to the second case. How much does the resistance change if the diameter is doubled? So in the second case, we are going to change the diameter of the wire. So now the diameter is doubled. So if we change the diameter of the wire, the only parameter which is going to be affected is the area of cross section of the wire. So radius in the second case, that is diameter divided by 2. That is a general formula. So diameter in this case is doubled. So 2d divided by 2, we get the radius of the second case to be d. So let us assume the resistance of the first wire to be R, that is rho into L by A, and the new resistance will be R dash. So R dash divided by R is equal to rho L divided by pi R square. So R is D in this case. So rho L divided by pi D squared divided by the original resistance rho L divided by pi R square. R in the original case is D by 2. So D by 2 square, and rho L gets cancelled, pi by gets cancelled, and we get R dash divided by R is equal to 1 by 4. That is, R dash is equal to 1 by 4th of original resistance, that is 0.25 times R. So when you increase the area of cross section of the wire's resistance is going to reduce. So in this case, since they have doubled the diameter of the wire, the resistance has come to 1/4 of the original resistance.